When we're trying to determine if there's a linear correlation between X and Y, ideally we'd have the raw data so we could take a look at the scatter plot. Looking at the scatter plot would allow us to see if there does appear to be linearity overall, if there's any outliers, influential points we have to worry about, clustering, all the reasons that we've looked at the scatter plot, we'd have that available to us. When all we have is the summary, it really boils down to, is the correlation significant? And to determine that, we're going to go ahead and it really boils down to, is the correlation greater than the critical value? And again, we're just looking at the number parts, plus, minus, that's just direction. We just want to know about the number parts. So when we're running through this, the first thing we're going to need if we're going to make that comparison is the critical value. And the critical value is going to be based on two things. It's going to be based on sample size, and it's going to be based on alpha. And once we have those things, we could go to table A6 and find that. So if we've got an N of 10 here and an alpha of 0.5, our critical value is 0.632. Now our correlation here is 0.703. So is 0.703 greater than 0.632? Yes, it is. And now, is there sufficient evidence to support the claim that there's a linear correlation between X and Y? Yes, it is. What you're going to see is whatever our answer is here is going to be our answer here. So in the next case, we have a sample with 8 pairs. That's N equals 8. And still a 0.05 level of significance. So there is our critical value. Our R here is 0.703, and 0.703 is not greater than 0.707, so we do not have sufficient evidence to support the claim of linear correlation between X and Y. Continuing on, we've got N equals 80 and alpha of 0.5. So our critical value there is 0.220. Our correlation is 0.279. So yes, the correlation was bigger than the critical value. So yes, there is sufficient evidence to support the claim that there's linear correlation between X and Y. In our next, we've got N equals 25 and alpha equals 0.05. That's 0.396. And we've got 0.279. Is 0.279 greater than 0.396? No, it is not. So no, we do not have sufficient evidence to support the claim that there's a linear correlation between X and Y. And if we continue on down the road here, let's clean that up a little bit. We've got 100 pairs, an alpha of 0.95, and there's 0.32. Is that greater than 0.196? Yes, it is. So yes, we have sufficient evidence to support the claim that there's a linear correlation between X and Y. And in our one down here, N is equal to 10, alpha is 0.05. So that's 0.632. Our R is 0.432. And no, R is not greater than the critical value. So no, there isn't sufficient evidence to support the claim that there's a significant correlation between X and Y.